All right, so we were talking about arrays. I'm expecting that you already know about arrays. If you know about them from Python, they're exactly the same as lists, except you can't append to them and you can't delete from the middle of them. That's it, right? And so with an array, you can step through it with a for each line, same as you can with Java and Python. Even in C++, you can do it that way if you're in the same context in which the array was allocated. If you're inside a function, then you can't do it that way. And so in C++, you have to pass the length of the array around, and it's really nasty. That's why we don't like C++. No, I'm kidding. It's a great language. Anyways, so you use a for each loop, and you give a variable type, same that the array was allocated with. Give a variable name. Doesn't matter what the variable name is, right? Call it Bob, as long as you have it, Bob down here. And you can step through them. I guess I'd forgotten that toString with a quote C turned it into a currency. Cool deal. All right, so you use for each when you want to access every array element in turn. But the iteration variable is read only. So you can access it, but you cannot put a new value in it. So searching an array using a loop. You just start at the beginning, go to the end. They show doing it two ways. Yeah, we can just do it one way. What lecture are we on?
The last one was P,
So we're on Q? All right.
Did you say O?
Q.
Q, okay.
We're on Q. All righty. Got to make ourselves a little array before we have any fun with it. All right. So an array of events. It's equal to, and let's put some numbers in it. And we're going to wind up searching the array for a 3, just because that's fun, and I know I typed it. I seem to remember a cartoon about 3 is a magic number. What did I do wrong here, gang?
That's Java.
Why don't I go ahead and give it a variable name?
Untitled.
Yeah, you're right. If it was Java, excuse me, another language, we'd put the square braces back there.
Oh, wait.
Java is twisted and allows the braces to go in both places, but it shouldn't, because the standard is to put it next to the data type rather than the variable name. But to make it compatible, the syntax a little more compatible with C++, they also support it there. I do not believe that C# is as generous. I think if we put the braces there, it's not going to work. All right, yeah, let me undo that. Okay. So what are we going to do? We need to find the position of 3. That's our goal, like if we wanted to change it to a 0 or something like that. So what is the position? 0, 1, 2, 3, 4. By the time I'm done, I'm hoping to figure out that where we found it at was at 4. Now normally I write this as a method, but just to stick it in the main code, because we can turn it into a method later, what do I need to know? Well, since I need a value that's going to step through this, it has to be an index-based loop. We can't use a for each loop because a for each loop doesn't have a counter, right? So I need a counter so that I know that that is at position 4. How would I know that? You might be able to call some kind of search function, but that'd be totally cheating. We're writing our own. Okay, so we need a counter. I'm just going to use the counter that the for loop's going to provide. And we need a variable found at. I'm going to set that equal to -1. And if it maintains that value after the loop, it means we never found it. And now we're going to write a for loop, an index-based for loop that just checks every value in turn. Once we found it, we're good to go, right? So for int I is equal to 0, because that'll be the first value. Keep going as long as I is less than the length of the array. Semicolon. Add 1 to I each time. And we're going to check. Is that value equal to our search value? Now, I forgot to declare a variable to hold our search value. Right? So, int target equals 3. That's the number that I'm trying to find. So, in the array, if that array value, IA subscript I, right, the current array value at that specified index is equal to a target, awesome possum, we found it. So we can set found at equal to that value, and then we can break out of the loop. There's no reason to keep searching after that, in most circumstances, right? Usually you say search and you want to find the first position of it, or you want to find the last position of it. There are times when you want to keep iterating through it, right, and taking note of all the positions where you find it, but not usually. So the simple search algorithm is going to look like this. We found it at index I, and we're done, so we can break. And lo and behold, that's all there is to it. We started at the beginning. We kept going until we either found it or the for loop completed because we never found it. How do we know if we found it? If found at is equal to its original value, then we never found it. So we're going to just have an if statement down here. If found at equals -1, that's our bummer case. We didn't find it. Yeah, since it's not working on my primary monitor, it's in widescreen mode. All right, so anyways, CW tab target plus quote space not found in array end quote. Got tired of using placeholders, so we just run it like that. Else we did find it. Since we only have one line under our if, I'm going to remove the braces. Else, CW tab, target, wait. Found target, end quote, plus target. That looks a little bit funny. Plus quote space at index space end quote plus found at. That's where we found it. Is this the most efficient way to search an array? No. The most efficient way to search an array is to sort the data and then start in the middle. Just like pick a number between 1 and 100. You start at 50 and then you get told, no, that's too low. So you jump to 75. Right? And if you have 100 numbers, or excuse me, if the range is 100 numbers and you use that binary search algorithm where you start in the middle and you keep starting in the middle of what's left, then it takes a maximum of 6 tries to determine whether it was there or not. This would take a maximum of 100 tries, right? Because it's got to start at the beginning and go all the way to the end. That is, if this array was 100 values long, right? It's not, so it's going to take a maximum of 1, 2, 3, 4, 5, 6, 7, 8. If they were sorted, we could use a binary search algorithm. Since this is so short, we really don't care, right? Who cares if we search, 9 times rather than 3 times? That's not strictly true, right? But, we're not writing something that's that time sensitive. If it was, we probably wouldn't be using C#. You'd be using C++. All right, I'm going to run it. I'm going to see what it does. That's the entirety of my code, other than the main method declaration being slightly off the screen. And I forgot to put my read key at the end, my read line. All right, so console.readline. CW tab, done, press enter. Yeah. All right. I got that stuff off the screen, but you've seen that enough. Alrighty, and yeah, the video is going to be a widescreen too. Really need to fix the monitor. Anyways, okay, so it found the target 3 at index 4. Let's search for something that is not in the array. Right, so if I come back up here and I'm going to search for the value 333, that's not in the array. Yeah, I don't know where to put it. Can I minimize this? No, probably not. All right. And 333 was not found in the array. So that's how you search the array.
Mine didn't show.
So arrays are all about loops. That's why you learn loops, and then the very next chapter should always be arrays. Right? So searching the array, yeah. If you're going to sum up the values of the array, you just create a sum variable to hold up, hold the total. And inside your for each loop, you increment that total by the current value. All right, so I'm going to go up here and I'm going to make a method called search, right? And we're just going to kind of copy most of this stuff from here and paste it into our method. So this is going to be a static and it needs to return an int search array, right? We need a target, int target. We need an array, int square braces IA. We need a variable inside called found_at. And once we have done those 3 things, we've handled all 3 of these declarations. We're pretty good. So int found_at equals -1. I could have just copied and pasted. Matter of fact, I'm going to copy and paste this entire for loop and its contents because I'm lazy. So I'm going to come down here, grab my entire for loop. I always like adding end for comments. All right. Grab my entire for loop, Control C it, come up here, paste it. Right. And then at the bottom, after the end for, but below the end of the method, we're going to return found_at. Classic search algorithm. On average, the efficiency of this is 1/2 the length of the array, right? Because sometimes it'll find it at the first record, sometimes it'll find it at the last one, sometimes in the middle, and if you add up all those things, divide them by the number of search attempts, you'd find out that, if there's 100 the array is 100 long, on average it'll take 50 iterations to find it. So it's certainly not the most efficient. Remember when I mentioned the binary search? Binary search takes the most like 6 hits, 6 searches to find it. That's a big improvement. And the larger the data range, the more efficient it becomes, because if you have 1,000 elements in your array, binary search takes only 11 or 12 or 13, I don't remember the exact number, instead of an average of 500. It is really good to be able to do a binary search. The only caveat is that it has to be arranged in sorted order. You can't do a binary search if the data is not sorted, right? Because if you can't say, well, you're too low or you're too high, position 50 was too low. If it's in random order, right? You know, if the numbers are random, you don't know whether that number was too low or too high. So for a binary search to work, it has to be in sorted order. So the deal behind that is that sorting is also relatively expensive, right? So if you're only going to do a single search in an array, don't bother sorting it. If you're going to do a lot of searches into an array, then go ahead and sort it and use binary search, right? So it's just kind of a, you know, judgment call. If you're only searching it a few times and the data set is not too long, don't bother sorting it. If you're going to search it a whole bunch of times, it becomes real important for that search algorithm to be efficient. So it's okay to sort it, right? That's also expensive, but you only do it once as compared to the 10,000 searches. All right, let's prove that it worked. So above here, we're going to call found_at again, passing in the target. Excuse me, we're not going to call found_at, we're going to call the search algorithm, passing in the target. So found_at, or whoops, yeah, found_at equals search array, and the number we are looking for is a 3, or why don't I pick something else, right? Mine could be 55, right? So I'm looking for 55, and what am I searching? Whoops, that should have been a comma. I'm searching our integer array. Feel free to copy these 4 statements and paste them underneath this search array. So this end_for is not in our search method. This end_for is in main. So here's what we're going to insert after the end of our for loop, before the console write line. We're going to insert found_at equals search array, parentheses, the number we're looking for, 55 or 77 in my case, and then a reference to the array itself. And then just go and, oh wait, I already had all that stuff down there. Delete what I just typed, and then go down here and do this, right? I confused myself. That's too bad. I'm going to zoom out to make sure that you get the position of what I just did. Sorry about that, but, right, this is inside main. We have a for loop. We print the results, and then we call search array instead of writing a for loop, and we print the results again. I'll pause and walk around just a second. Okay, so it found 333 at index 5. Oh, why am I getting that? Can anybody tell me why it printed out 333 2 times? And the answer is that variable right there. What did target equal by the time it got here? Did it equal 55?
No.
No, because we never said it equal to 55. Right, so let's reset it. Target equals 55 semicolon. And this is above our call to search array. And then we're going to look for that target. That's typically how you implement a search, so that you can just call it over and over and over, right? You stick it in the method and you forget about it. And if you need to write multiple search algorithms, yeah, then you can do overloading, where you pass in, you know, an array of ints as opposed to an array of strings or doubles or whatever. Now I'm pretty dang sure that there is a search method built into the array class, so normally you don't have to write this, but you need to know how. And that's why we spent some time talking about it, just because you've got to understand the concepts of loops and how they interact with arrays. All right. Going to pause this, make sure everybody's doing okay.
No.
And I heard a heck no over here. No. All right. So that's how you search the array. Let's go take a look. Using a for loop. Yep, just like that. All right, here's what they're doing. Is they're setting a value called isValidItem. They're setting it equal to true. And they're not even checking. They're not even returning, right, what X was, what position it was. So that's kind of lame. But. And then you can do the same thing with a while loop. That's not what this is showing. but you can break out of it. Change X to force a break out of the loop. So if you ever find it, then you set X equal to the maximum value it needs to be to bail out. They're just doing that to try to avoid a break. That's also lame. Use break statements. Okay. Using a while loop, search an array. You can use while just as easily as for, because anything you can write with a for loop, you can also write with a while loop. Searching an array for a range match. This is more like fundamentals of programming. Yes, you can find the pair of limiting values between which a value falls. I'm going to skip that. Right, so here's your ranges, right? And if the range is between 1 and 13, you get a 10% discount. If it's between 13 and 50, you get a 14% discount. If it's between 50 and 100, you get an 18% discount. And if it's between 100 and 200, it's a 20% discount. And I think maybe I goofed that up off by 1 so that if it's above 200, you get a 20% discount. If it's above 100, you get an 18. If it's above 50, you get 14%. If it's above 13, you get 10%. And if it's above 1, you get 0%. So you just have a while loop that searches through it, and when you finally find the correct one, the correct position, where to stop, then these are a parallel array, and so you just set it equal to the discount for that value that it found. So it just loops through whatever your data is, looking for a specific number, right? The number that we're looking for. I'm not even seeing where they stored that. And we keep looking until we find a value that is less than the number of the discount range lower limits. So using binary search, sort, and reverse methods. Yeah, so why write our own search method if we can depend upon the array class to give them to us? We're going to blip back over here. We're going to sort our data. So ia.sort. Ooh, that's not working. Let me, I went a little bit too fast. The system.array class contains a variety of useful built-in methods. How are you going to sort it? You're going to sort it using array. Okay, they're cheating. The data is already sorted. That's a big cheat. We're going to call array.sort by passing it an array like this. So we call array.sort. We pass in the array right there. Right, we already have an array of names here. We call array.sort names, and that monkeys with the array and sorts it, and so then we can print it out in sorted order. All right, so let's do that. Arrays dot, okay, fine, if my memory is a shot. It's array.sort. Why isn't it popping up my little helper list? Oh, because I spelled it with a Q. That's brilliant. Array.sort, parentheses, our array. Now if we print out the array, we're going to see it in sorted order. Let's print it out both ways. Let's print our data beforehand and afterhand. Let's use a for each loop to print it. Can we just print my CW tab IA? I think we established that we can. If not, we'll have to write a for loop. And then after the data has been sorted, let's print it again. Okay, I was wrong. Some languages have a two-string method which array prints the data in a pretty fashion. This one did not. Okay, fine. We're going to write a for loop here and a for loop here. The better solution would be to go and create a method, right? So for each parentheses, int value in array, CW. No, I don't want to do console write line. Let's just print it out. Console dot write, parentheses, that value plus a space. And why don't I put that on the next line, just because there's no reason. Well, the only reason to have done it on one line is to try to put as much data on the screen as possible. I'm just going to copy and paste that below my call to array.sort. Now both of these calls to a console.write line have disappeared, but I need to add one back, because after we've printed out a whole bunch of stuff on the same line, we just need to hit the return key and go back. So CW tab tab, there we go. That gets us back to the first column. Now copy those 3 lines and paste them after the array sort. There we go. Before the sort, after the sort. Why would you want to sort it? Well, there may be times when the user wants to see, how their data sorted. I want my MP3 player to, display all my song titles in order so that I don't have to go crazy looking for my favorite Jay-Z song. Also, so you can do binary searches. Let's search the array for a value using a binary search. And was it an arrays? No, array dot binary search. And do we pass in the name of the array? Yep, we do. IA, comma, and what are we looking for? Well, I know I have a 55. Pretty sure I do anyways. But I need to store that value, right? Found at is equal to that. Or to be better, I should store the target, right? So target equals 55. Found at target. And let's print it out. We have some print statements already, so I'm going to steal these 4 print statements from above our print loop, copy and paste it below our call to binary search. Now this is all still in main.
I'm missing something.
I'll be right there. Copy that, paste that. All right, so where are we in our code? We are underneath all the loops and the call to search array. And then we have a loop to print our array. And then we call array.sort. We print our array again. And then we set a target and we call binary search. And then we just do the same thing. Print whether we found it or not. Let's make sure it works before I go walking around. All right, and so indeed it found 55. What if it didn't? What if we didn't find it? I'm going to look for 56. I do not believe 56 is in my array. Now check this out. It says found the target 56 at index -5. Why is it doing that? Well, if it returns an index not of -1, -1 no longer means didn't find it. Any negative value means didn't find it. And it can equal something other than -1. What it's telling us is where in the array it would have been if it had found it. So we were looking for 56. It wouldn't have been in position 0. It wouldn't have been in position 1. It wouldn't have been in, because this is sorted data, 2. It wouldn't have been here, 3. It would have been here, 4. Now, since we can't start counting at 0 because there's no such thing as -0, they're calling that -1, -2, -3, -4, and it would have been here. And so that's what it's telling us. In case we need to know where it would have been. So I need to modify my code so it doesn't say equals -1, but to make it less than 0. So if found at is less than 0, that means we didn't find it. Whoops. Why don't I make that good syntax? All right. Let me make sure it works, then I'll walk around. 56 is not found in the array. Sure enough. All right, so let's make some notes. Use a loop to search an unsorted array. All right, a for loop, a while loop, either one will loop, work. Let's see if there's a search command that'll search an unsorted array. If I do ia.find, nope, .search. Oh, really? Oh, well.
Should be fine.
I would have thought it was fine. All right. How about array.find?
It just says sort.
Yeah, there he is. Find an element in an array.
Mm-hmm.
Okay, so anyways, if you don't want to write your own loop, research how to use .find. I want you to know how to write your own loop, because you can always Google how to use this specific find method. Okay, so you use a loop to search an unsorted array. Use binary search, which is in arrays.binary search, to search a sorted loop, but data must be sorted. This is expensive in terms of processing time, but binary searches are so much more efficient that it's worthwhile to sort the data if you are going to be doing, say, more than 1 or 2 searches into the data. I don't know if that's the threshold, right? If you're going to be doing several, lots, right? Many. So in something like a database, you're using MySQL or something like that, they have indexes to maintain the order, right? The data itself is stored in some random order, but they have an index, right? So, you have an index on the, the employee ID or whatever. And you can be darn sure that that index is sorted so that if you say search for an ID that matches a specific number, it can do a binary search on it. So if you have an index for that specific column, that specific field in your database, then the searches are going to be a lot faster. And when you insert new data into the database, it goes ahead and modifies the index, a little bit in order to keep that sorted.
So what are we writing here? Just similar to what we just got through doing. Let's see the statements you have down, and this is expensive in terms of processing time.
Yeah, it's expensive in terms of processing time. Now, if you have some other reason to keep your data sorted, like because it's nice to display it, that's totally cool. But there are times when you don't want to sort your data. For example, if you have parallel arrays linking up, months to rainfall, it'd be a real bad idea to sort your rainfalls because then they wouldn't match the months. Or it'd be a bad idea to sort your months, right? Because April would be at the first of the list, and that'd be confusing. And then they still would not sync to the values.
So these are things that we have printed out according to what we are sorting.
Yeah, if you want to print your data and you want it to look pretty and it's appropriate, it's not a parallel array, go ahead and sort it if you want. Especially if the homework says to. Or if a user asks, I want my data sorted. All your MP3s need to be sorted. You want your names sorted by, last name, comma, first name, that kind of business.
So this will be an entry by the user.
Yeah, your requirements, would come from your users as to whether the data needs to be sorted or not. The reverse method. Say you want to swap your data for some reason. It doesn't sort the data elements, it only rearranges their values in the opposite order. But when we sorted it, it wound up being smallest to largest. If we call dot reverse on it, now the data is going to be largest to smallest. Maybe that's going to be useful. Maybe not. So let's look to see how you reverse it. It should just be the array name dot reverse. No, it's probably going to be array dot reverse and then pass the array name in. Let's go peek. Use it by passing the array name to the method. All right. So reverse our array dot reverse parentheses, our good old array. And now let's grab our for loop to print it out again.
That's all under your pause.
I'm so sorry, pardon me.
That's all under your pause.
Oh, you're right. This stuff should be above our pause. I'm going to cut those two statements and put that above my press enter. Right. And let's print it out again. So those two statements, well, one statement plus comment, needed to be above the read line. I need a for loop to print my sorted array out, my reversed array out, excuse me. So I'm going to copy that, paste it, and when we print it out, we're going to see that the data is now sorted, reversed. I keep saying sorted. The data has already been sorted. Reverse does not sort your data. But if your data is already sorted, great. You know, it just puts it in reverse order. Okay, so now that the data has been dot reversed, we can see it in the opposite order. Alrighty. I think that's about enough. What am I going to inflict on y'all? I'm going to inflict upon y'all an assignment called orcs versus elves. What orcs versus elves is you have two arrays, one representing the health of the elves and one representing the health of the orcs. So if you're a video game fan, then you're used to the idea that each character could have a certain number of hit points. And then you just make the first character in one array fight the first character in the other, and whoever loses takes some hits. So that's reduced from the array. Now this is actually going to be optional homework. It's going to work as one of the projects that I'm going to offer to you. So we're going to have end of semester projects. If you do a project, you don't have to take the final exam. So that's kind of cool. And this one will serve as one of your possible projects. And I will give you all of the list of the other possible projects. So let's go look. See if we can find elves versus orcs real fast, and I'll explain it. All right. Look at that. It used to be exercise 5B. I used to be really mean and assigned us at the very beginning of the semester. All right. So this seems to be a helper for it rather than the actual assignment itself. Let's go look at the other file. Wish there was just a next button like there is. Maybe I saw one. Like there is for y'all. All right, I don't know where the assignment itself went. Oh, here it is. Right there. It was right in the middle. So if for some reason I give you the hints before that, but this is just to create a random number generator, right? Here's how you generate a number between 1 and 6, like you're rolling a die, you're playing Yahtzee, whatever. Okay, so assignment. Write a battle simulator that will fight an array of elves against an array of orcs. So you're going to create an array of 10 ints. You're going to name that array called orcs. You're going to initialize every element in that array to a value of 20. That's the orcs' health. They each have 20 health points, hit points. Then you're going to create another array same size called L's. Initialize every element in that array to 20. They have the same health. So each attack is decided by a die roll from a 6-sided dice. So you'll need to generate random numbers between 1 and 6. Every attack consists of one elf fighting one orc. Everyone rolls one die. Whoever rolls higher wins. The loser deducts the difference. So say the elf rolls a 6, the orc rolls a 4. That's a difference of 2. The orc is going to take 2 hits, and their number in the array is going to be reduced by 2. So the first elf in the array fights the first orc in the array, and so on. The second elf in the array fights the second orc, and so on. When their hit points hit 0 or less, then they are defeated. You could say they died, or maybe they just go take a chill somewhere because they're not feeling good. So a round consists of a run through from the beginning to the end of the arrays. So what you really want to do, though, is after a round is done, you're going to want to sort the data so that the strongest elves are fighting the strongest orcs. So here's an example. We have an array of elves. We have an array of orcs. If elf number 0 rolls a 5 and the orc rolls a 5, there's no hits. Elf number 1, the second one, rolled a 2, but the orc rolled a 3, so the elf took 1 damage because there's a difference of 1. Elf rolled a 2, the orc rolled a 6. This time, the orc won by a lot, so that elf took 4 hits of damage. The third elf, position 4, rolled a 6. He beat the orc who rolled a 4, so the orc's going to take 2 damage. So then when we look again, this is after the battle, and then you sort it and reverse it so that the high value elves are in front and the high value orcs are in front. And so then, some of these guys took damage and some of them didn't when they rolled the same number. And so eventually you're going to wind up when the entire array consists of values of 0 or less. And that means that they don't have any health left in their line of orcs at all, and the game is over. And so the elves win and the orcs are defeated. All right, then there's an extra credit option here. So this is a possible project. There's several other possible projects. I will post a description of the projects out in the announcements this evening so you can look at them. One is to write a football game, another is to write a baseball game, another is to write a game called CS Fighter for C# Fighter. If you've ever taken my class and seen Pie Fighter, it's the same thing, right, where you have 2 characters with armor and hit points and an attack value, and they just fight until one of their hit points, things like that. So there's a choice of about 6 different projects. You can pick the one you like, the last one being Hangman. I will add a comment here to the code here, is if you do the Hangman project, if you copy your code from the internet, you fail. Bad things happen. You get, academic dishonesty. And how can I tell? Well, I'll be able to tell from your coding style. I know who's been writing the sophisticated, you look like you've been writing C# code for 20 years, and so I guess you're just taking this for the credit. And I can tell, I'm familiar with your code by now, and usually I can Google up the Hangman code and find where it was copied from the internet. The only reason I'm harping on this is because, quite often, people wait until the last week to do it, and then they panic, and so they go and they search, find the code. Don't do that. If you get stuck on it, ask me for a flow chart or show me your code and I will help. That way you're not going to fail, right? Even if your Hangman game doesn't work, it's better than turning in something you copied from the internet. Trust me on that. Okay. So if you get enough credit on it, the project can replace your final exam score, right? If you earn 100% on your project, you earn 100% on your final. And then you can decide, well, I'd rather take the final, because I only got an 80 on my project or whatever. So, I hope that makes sense. That makes sense, both of y'all?
Dropbox.
Yep, why don't I make a drop box so y'all can head out of here. And that says so in the project descriptions as well, so you'll remember that.